Good afternoon, everyone. This is Kapil Sahu, Associate Professor, IT Department from Acropolis Institute of Technology and Research, Indore. Today, I just want to discuss the topic from one of my subject, Computer Graphics and Multimedia, that we are teaching in IT third year, 6M. So today's topic is transformation. Before starting the transformation, we need to understand the basic thing of the transformation. Transformation means whenever we want to change the shape, size or orientation of any object or the image that is running on the screen of the monitor. So whatever method we will use for change, it is called the transformation. Actually, there are two basic types of the transformation: geometric transformations and the modeling transformation. Geometric transformation are the basic transformation, means translation, rotation and scaling. Modeling transformation means whenever we want to create any scene according to the demand of the video or the user, then this is the modeling transformation. Other than the geometric and modeling transformation, there are two other transformations, that is called the reflection and shear. Reflection means we will able to get the reflective image, and shearing means whenever we want to produce the distortion in the shape or the size. So this is the transformation. Before starting the other forms of the transformation, we just need to focus on the basic types of the transformation, that is geometric transformation. So first one is the translation. 2D translation, we can perform a translation into two-dimensional space. Suppose there is a pixel having coordinate value x comma y, that is its previous coordinates. If we want to translate this coordinate to the other position, means by tx value in x direction and by ty value in y direction, then this type of transformation is called the 2D translation. And the equation of the translation is x dash equal to x plus th, y dash equal to y plus ty, where x and y is the old coordinates, x dash y dash are the new coordinates after the translation, and tx ty are the translation factor in x and y direction. We can also transform this into matrix form. Matrix form means we will divide the equation into the matrix representation, where T is the translation matrix that include the 2 into 1 matrix Tx Ty. Other one is the new coordinate matrix that includes the new coordinates that we will get after the translation. And P means the matrix that is the old coordinate matrix that were the original or the basic coordinates before the translation. So the equation will be P dash is equal to P plus T, that is the matrix equation for the 2D translation. 2D translation, that is I told you, whenever you want to change the shape, size or orientation of any object, that is called the geometric transformation. 2D translation, to move a line segment, apply the transformation equation to each of the following line endpoints and zero the line between the two endpoints. Means whenever we will connect to the 2 points, then it will create a line. So we can also perform the translation on a pixel, on a line, on a polygon, or on any image. Second one is the rotation. Rotation means if we want to change the orientation, or you want to rotate any object by any angle, so this type of transformation is called the rotation. Here we can show the translation of a triangle by an angle theta. Theta is the orientation angle. We can divide this rotation into two types. First one is the rotation about origin, whenever we want to fix the origin as one of the point of the object. And second one is the pivot point. Pivot point means whenever the object having the fixed point other than the origin. So here we are representing the pivot point by the xr and y. Here is the equation that we are going to use for the 2D translation, but first we need to understand the equation of the rotation. We need to be aware from the some geometric equations that we students already taught by the faculties in the 11th, 12th. So this is the equation of cos A plus B cos A minus B. We all are aware from this equation. This is the basic matrix, or we can say the rotation matrix for the rotation, where P dash, as I initially told you, new coordinate matrix, R will represent the rotation matrix and P will represent the old coordinate matrix. If we will multiply all the matrices, then we will able to get the straight equations for the rotation. This is the equation for the rotation about pivot point, where x or y are the pivot point. If we will pivot the pivot point to the origin, then we will get the equation for the rotation about origin. And if the pivot point is other than the origin, then we will put the value of x or y in the equations, the value of rotation angle theta in the equation, and we will get the transform over the rotated point by this equation. So we are going to divide the rotation into two types. First one is the rotation about origin, second one is the rotation about arbitrary or fixed point. Third one is the scaling. Scaling means whenever you want to increase the size of the object, if you want to decrease the size of the object, if you want to just there is no change on the object, if you want to just make it uniform during the complete motion, then we'll use the scaling. Scaling, whenever the value of scaling factor, as I told you, we were using the tx and ty in translation. As it is in the scaling, we will use sx and sy, where sx is the scaling factor in x direction and sy is the scaling factor in the y direction. So here, if value of sx and sy if greater than 1, then the size of the object will be increased. If the value of sx and sy is less than 1, then the size of the object will be decreased. If sx and sy both are equal in values, then there will be the equal change in both directions. That is called the uniform scaling. So this is the scaling. So I told you about the basic types of the transformations right now. As we discussed the rotation about a pivot point, A same as in the scaling, that second scaling, that is called the scaling about fixed point, where xf, yf are the fixed points. If the value of sx and yf will be equal to the 0, then we will get the basic scaling equations. If the fixed point are other than the origin, then we will put the value of x and fyf in the equation. We will put the value of sx and sy in the equation. We will put the initial, or we can say that the old coordinates value of the image or the object as x, y, and we will get the new coordinates that will be the coordinates by which we will get the scaled image. So this is the equation that will represent the scaling. And I already discussed that if the value of s and x, y varies, then what will be the outcome on the size of the object or the image. Matrix representation of homogeneous coordinates. So as we discussed, there are three types of the transformation: basic transformation, translation, rotation, scaling. And whenever we will perform the different types of the transformation in a single sequence, means first you want to apply the translation on image, any image. After translation, you want to apply rotation on an image. After rotation, if you want to apply scaling on any image, means any type of sequence that consists of translation, rotation, or scaling is called the homogeneous transformations, or is called the composite transformations. For composite transformation, the coordinate that we are using is called the homogeneous coordinates. So we need to aware from the homogeneous coordinates. Homogeneous coordinates means whenever we want to perform the composite transformation,